Pluto is a faraway and confusing planet that was once a part of our close-by-planet gatherings planetary family. However, progressing, disturbing announcements by leading astrophysicist Neil deGrasse Tyson and MIT's Michio Kaku have brought Pluto back into the spotlight with a shocking revelation. They suggest that this cold world is on a potential brief trajectory with Neptune. Yet, how should this happen, and what may be the results of such a tremendous event? Are we seeing a charming, grandiose idiosyncrasy, or is there something else to this coming huge accident? Join us as we examine the potential results of a Pluto-Neptune impact. Pluto, a former planet that was downgraded to a dwarf planet partly due to its unusual orbit, remains a subject of interest and study in the cosmic community. As demonstrated by recent predictions by leading scientists, Pluto's orbit is perilously close to Neptune's. Leading astrophysicists Neil deGrasse Tyson and Michio Kaku are both raising the alarm about a potentially hazardous collision between these two planets that could pose a massive risk to Earth. How is such an event even possible? Pluto's orbit around the Sun is unlike any other planet in our solar system. It takes an astonishing 248 years to complete a single orbit, meaning that since its discovery in 1930, it hasn't even completed one full revolution. However, the intrigue doesn't stop there. Pluto's orbit is marked by its especially elliptical shape, deviating significantly from the nearly circular orbits of the major planets. What makes Pluto's orbit even more interesting is its inclination of 17 degrees to the ecliptic plane. The path Pluto follows is much steeper compared to the other planets. This inclination and erratic nature add layers of complexity to its orbital pattern. Perhaps one of the most fascinating aspects of Pluto's orbit is its convergence with Neptune's path. For nearly 20 years in each orbit, Pluto actually comes closer to the Sun than Neptune, defying what we might expect from their positions in the nearby planetary group. This leads to the natural question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational influences of other planets. The study of Pluto's orbit began shortly after its discovery. Initially, astronomers tried to figure out its surprising path. Unlike the other planets, whose orbits lie relatively close to the ecliptic plane, Pluto's orbit stood out due to its steep inclination and erratic shape. The mystery grew with the realization that Pluto's orbit actually crosses Neptune's. The stability of Pluto's orbit amidst these complexities is a testament to the intricacies of space mechanics. The three-body problem in space deals with figuring out how three objects, such as Pluto, Neptune, and the Sun, move and influence each other through their gravity. It's like trying to predict where they will go based on where they start and how they pull on each other. For Pluto, this problem illustrates how its orbit, Neptune's path, and the Sun's gravity all interact in a complex way. The terms alpha libration and degree libration, along with the V-Zk oscillation, are essential to this puzzle. According to astrophysicists, what keeps all planets in their orbits is a phenomenon known as alpha libration. In the case of Pluto and Neptune, this term essentially means that when Pluto crosses Neptune's orbit, it is positioned about 90 degrees away from Neptune. This spatial separation is key to preventing their paths from intersecting. Degree libration, on the other hand, refers to the vertical motion of a celestial body in its orbit. For Pluto, this means that when it comes closest to Neptune or any other giant planet, it is positioned significantly above their orbital plane, providing an additional layer of protection from potential collisions. Another important factor in this situation is the V-Zk oscillation, named after three researchers, Bond, Zippel, and Kai, who studied how objects move in space. It refers to how three celestial bodies, such as Pluto, Neptune, and the Sun, pull on each other with their gravity, influencing their movements. For Pluto, the V-Zk helps explain why its path around the Sun is so unusual. Despite Pluto's orbit seeming chaotic, this oscillation helps keep it moving smoothly. Understanding its orbit is crucial, as it gives us a clearer picture of the planetary system's dynamic nature. The case of Pluto shows how even the most seemingly unstable orbits can achieve a kind of harmony through the complex interaction of gravitational forces and orbital mechanics. It also highlights the importance of continuous observation and study of these phenomena to better understand our position in the universe. Exploring the depths of space often forces us to confront the odd nature of celestial bodies, and Pluto's orbit is a perfect example of this oddity. The concept of orbital chaos, which refers to the delicate dependence of a celestial body's orbit on its initial conditions, is strikingly demonstrated in Pluto's case. This means that even slight variations in the dwarf planet's position or speed can dramatically alter its long-term trajectory within our solar system. Pluto holds a unique place that challenges our understanding of planetary classification and dynamics. Since its discovery in 1930, Pluto has undergone extensive study, leading to significant revelations about its structure and behavior. One of the most captivating features of Pluto is its surface, which is a complex tapestry of ice, rock, and other compounds. NASA's New Horizons mission, which flew by Pluto in July 2015, provided stunning data about this distant world. The surface of Pluto is characterized by vast plains, towering mountains, and deep valleys. One of the most extraordinary features is the Sputnik Planitia, a massive heart-shaped plain made primarily of nitrogen ice. This region showcases a variety of landforms, including large ice shelves and what appear to be flowing glaciers. The presence of these features suggests that Pluto may still be geologically active despite its vast distance from the Sun and low temperatures. Another fascinating aspect of Pluto is its atmosphere, which is primarily composed of nitrogen, with traces of methane and carbon monoxide. Pluto's atmosphere is thin, but it exhibits interesting seasonal variations. As Pluto moves toward the Sun in its elongated orbit, its atmosphere can expand and contract. This dynamic behavior reflects the complex relationship between Pluto and its environment. During its closest approach to the Sun, some of the atmospheric gases may freeze onto the surface, while as it moves farther away, these gases can sublimate back into the atmosphere. The interaction between Pluto and its largest moon, Charon, further complicates the system. Charon is relatively large compared to Pluto, with a diameter about half that of Pluto itself. This size ratio means that the two bodies revolve around a common point in space, rather than Pluto simply orbiting Charon. This unique relationship contributes to the complex gravitational dynamics in the region, affecting the orbits of other objects in the Kuiper Belt. The Kuiper Belt, a region beyond Neptune populated with small icy bodies, is home to several other dwarf planets and potential impactors. This belt is a repository of ancient material from the early solar system, offering scientists a glimpse into its formation. Pluto's orbital characteristics may provide insights into the movement patterns of these distant objects, suggesting that interactions with larger planets may have played a significant role in shaping their current orbits. One of the key implications of understanding Pluto's orbital mechanics is its potential impact on our understanding of the solar system's evolution. The gravitational influences of large planets may have played a crucial role in sculpting the orbits of smaller bodies in the Kuiper Belt and beyond. Understanding Pluto's orbital mechanics also provides valuable insights into the evolution of the entire solar system. The gravitational influences of the larger planets, particularly Jupiter and Neptune, may have played a critical role in shaping the orbits of smaller bodies in the Kuiper Belt, such as Pluto. This dynamic interaction could have caused the scattering of material throughout the outer solar system, influencing the trajectories of comets, asteroids, and other celestial objects. By studying these interactions, astronomers are able to piece together the history of our solar system, uncovering clues about its formation, evolution, and the forces that have shaped it over billions of years. In particular, the study of Pluto's orbit provides a unique window into how objects beyond Neptune move and interact, potentially offering a better understanding of the outer regions of the solar system. Moreover, Pluto's unusual orbit challenges our understanding of planetary classification and its place in the solar system. In 2006, the International Astronomical Union, IU, redefined what constitutes a planet, downgrading Pluto to the status of a dwarf planet. This decision sparked debate and continues to generate discussion within the scientific community. Some scientists argue that Pluto's complex orbit and intriguing characteristics deserve it a place among the major planets, while others maintain that its small size and irregular orbit disqualify it. Regardless of its official classification, Pluto remains an object of immense scientific interest. The New Horizons mission, which flew past Pluto in 2015, revealed stunning details about the dwarf planet's surface, its moons, and its atmosphere. The data collected by New Horizons has deepened our understanding of the outer solar system and raised new questions about the processes that govern these distant worlds. From its icy mountains to its dynamic atmosphere, Pluto continues to surprise and fascinate scientists and the public alike. As we look to the future, the study of Pluto, its orbit, and its interactions with Neptune and other bodies in the Kuiper Belt will remain a central focus of planetary science. The potential for a collision between Pluto and Neptune, while unlikely, serves as a reminder of the complexities and the unpredictable nature of the solar system. The delicate balance of gravitational forces that prevent such an event from occurring also underscores the importance of understanding these celestial dynamics to predict future changes. In the end, Pluto's story is a testament to the dynamic nature of the cosmos. It challenges our understanding of the solar system, defies conventional categories, and continues to spark curiosity and debate. As we continue to explore and study these distant worlds, we will undoubtedly uncover even more mysteries about the forces that shape our universe and our place within it.